This question is using linear regression, and we're told that here where it asks us to find the regression line, if we read ahead we can also see that it's talking about Pearson's product moment correlation, which tells us that it's a linear R-value with Pearson's approach. So you can often find a little bit more information just by reading through the question. So this is a cyclist who records the gradient of ascent that they've done and then the time that it takes. So essentially this is our x coordinate and this is our y variable. So our x and y variables. So the first one is to find the regression line t on g. So to do that, we're going to go to our calculator and we're going to go to statistics and edit. And you can see that I've typed in here the data for the table that we were given. We can then go to statistics, go across to calculations, and then linear regression. Make sure that the list 1 is in the x and list 2 is in the y, and then we're going to calculate. So the linear regression line is this given to us here, y equals ax plus b. The a value is this and the b value is this. So when you write it into your exam paper, you literally just sub in the x and the a and the b values. So we're going to do that here. So question A is y is equal to 0.799 x plus 2.14, or to 3 significant figures. However, the question wasn't x and y, it was g and t, and that's what's asked in the question. So in order to get the full marks, I actually need to change my variables to g and t, which is what the question is talking about. So always make sure you double check what the variables are that you should be using. And then part B asks you to explain how strong the correlation is using the R value. So we can see here the R value is also given to us, and to 3 significant figures it's 0.996. Whoops. And we would need to write some sort of explanation with that. So there is very strong, I would say that's very good, positive correlation. You can also link it to the context. So there's very strong positive correlation, which means that as the gradient increases, so does the time. Part C then asks you to estimate how long it takes for him to ride 1 kilometer up the hill at 17 degrees. So for this one, or 17%. So for this one, the G value is 17, and you're substituting that in to find how long it would take. So we're going to use the line of regression that we calculated earlier, and we're just going to substitute that value of G in. So 0.799 times 17 plus 2.14. And that gives us 15.7 minutes to 3 significant values, or 3 significant figures. And then for part D, it asks us why it would be inappropriate to use it for 22 minutes. So the reasoning here is that it is extrapolation. Okay, 22 minutes is longer than we've currently tested. Okay, the longest that we have is 20 minutes here in our table. Okay, so therefore 22 is outside of our range of data. We don't actually know what's going to happen, and therefore it's extrapolation. So the marks for this question, the first part is 2 marks. One of them is for the answer, and the second one is for having the correct variables. So you must make sure there that you've got the right variables. The R value is then worth 1 mark as well, and then the explanation is also a mark. For part C, there is a method mark given as well as an answer mark. That means if your line of regression was incorrect in part A, but you've shown that you've substituted 17 into it, you would still get the marks. And then at the end here, there is a reasoning and an answer mark for your explanation of why it would be a bad model to choose.